Hi, welcome back. Today let's learn how a rock breaker actually works. Rock breakers are used in construction equipments for blasting the bigger rocks into small manageable sizes. Like for transporting the rock pieces, it need to be made into small manageable size so that it can be carried on a truck. So what we do use is a rock breaker. This is a rock breaker over here. It's installed on a construction equipment so that the rock can be broken into small manageable pieces. So this is a rock breaker, how it looks like, the internal components of a rock breaker. So in this video so this is a rock breaker. The internal components of the rock breaker are also marked over here. So in this video we'll be learning about how a rock breaker actually works. I mean the working principle of a rock breaker, the basic working principle. So before that, let's identify the components. So here the casing of the rock breaker, that's called as a cylinder. So it has a casing, and we have a through bolt because it is like in three sections. So for joining them, we have a through bolt over here on the top, two of it. Then we have a head cap here. This portion will be filled with nitrogen gas, which will be at a pressure of nearly 14 bar to 18 bar over here. 14 to 18 bar pressure, that's a nitrogen gas over here. Then we have the piston over here. So this is the piston, and this is a chisel pin which will be supporting the chisel so that it can move in this this section. And this is a chisel, and actually this is called as a tool. This will be the part which will be engaging with the rock. So this is our rock piece over here. So chisel will be engaging with the rock. Now let's see how a rock breaker exactly works. So what happens is that the operator of the construction equipment will be keeping the rock breaker on the rock. When it is elevated up like this, that means when the tool is not touching the rock, the braking application is not happening. But when the operator keeps the breaker on the rock and presses it, what happens is that the tool tends to move upward. That means the tool moves upward slightly. That means the tool is connected with the piston over here. So the piston also moves upward, and a pressure is exerted on this nitrogen gas. So the pneumatic pressure happens over here, and the nitrogen gas further compresses. So we already have a 14 to 18 bar pressure over here. So as it compresses further to a limit, this nitrogen gas will exert a pressure back on the top of the piston. So that will result the piston to hit back on the chisel. So initially, when the tool is exerted on the rock, the tool moves upward. Simultaneously, the piston moves upward, and a pressure is generated over here. And as the nitrogen gas compresses, that nitrogen gas exerted pressure back on the piston, which results the piston to exert that pressure back on the chisel or on the tool, which result in the movement of the chisel towards the rock. So that's the first stroke. First stroke happens when the pressure of the nitrogen gas in the head cap exert the pressure back on the piston, and the piston hits the chisel. So we get the first stroke there. Then consecutively the next stroke will happen because we have a control valve over here which will actually support the next braking applications. The control valve, it is hydraulically operated over here. So the hydraulic oil will be going towards different ports of the piston. As the piston moves up and down, different ports will be opening and closing, and resulting that the oil will reach here, and the oil from the return also goes back towards the control valve. And also as it moves down and as it moves up, different ports will open up and close. Simultaneously, the hydraulic oil will move to different directions of this piston, resulting the piston to move up and down. So actually it works like a hydraulic ram. Different directions oil will be going, and resulting due to that pressure or that variation of pressure at different ports, the piston will move up and down, resulting in it hitting the chisel or the tool, which keeps the further application of the rock breaker. And when this tool is lifted up, simply we lift up the tool, the braking stops over there because the tool will not have any load. The braking application will be stopped. So that's basically how a rock breaker works. and towards the left side we can see an accumulator over here with a diaphragm. So this also will be filled with nitrogen gas. Depending on different type of rock breakers, there will be a pressure varying from like 40 bar to 80 to 60 to 80 bar will be here. 40 bar varying from 40 to 70 bar will be here. It is to avoid the hydraulic vibrations inside the breaker, because when the oil is moving to different directions and moving up and down, what happens is that there is a chance for vibrations inside the hydraulic unit. So to avoid that, this diaphragm will move backwards or frontwards to manage the hydraulic vibrations. So this will be actually nitrogen gas filled in. So when we excess pressure is happening over here, the diaphragm moves backwards and accommodates that pressure, and we need pressure outward. What happens is that there is a less pressure or a negative pressure happening here. What happens is diaphragm moves outwards, which manages that over there. So that's the function of the accumulator. It supports the hydraulic system inside the rock breaker to maintain the required hydraulic supply and pressure, which avoids the hydraulic vibrations inside the system. So that's how basically a rock breaker works. So I believe you got the idea of the working of a rock breaker. And if you like this video, please click the like button or drop a comment, and you can ask your doubts also through comments. I will be happy to reply to you. You can also subscribe to our channel for more technical videos. Thanks for watching this video.